what if your code could think, like, should I give this person a discount? Or is this kid old enough to watch that movie with all the explosions? Well, JavaScript can't exactly feel emotions. Yet. Please don't. Sam Altman or Google or Claude. Who even is Claude? But please don't. No emotions for JavaScript. But it can make decisions. And today, we're going to see how it thinks using operators and how it acts on those thoughts with if-else and switch. Let's decode JavaScript's brain. Let's talk operators, the tiny brain cells of JavaScript. One by one, here's what they do. We have arithmetic operators. They are basically math. Addition adds two values together. Subtraction subtracts the second value from the first. Multiplication multiplies two numbers. Division divides the first number by the second. Modulus returns the remainder of a division. Exponentiation raises the first number to the power of the second. Increment increases a variable by 1, and decrement decreases a variable by 1. Then we have assignment operators. These let you assign values and combine logic in one go. Add and assign adds the right value to the variable. And you can do the same with all the other arithmetic operators we just learned. Comparison operators. These operators, like the name implies, are for comparing. Let's go over some very important ones that I'll explain in detail. Equal to, lose equality. This one checks if two values are equal, but it doesn't care about type. JavaScript will try to convert one side to match the other before comparing. Why? Because JavaScript says, oh, a string and a number. Let me just convert that real quick. 10 as a string becomes 10 as a number, and the comparison passes. It's like comparing apples and apples. JavaScript says, close enough. Equal value and equal type. Strict equality. This is the grown-up version of equal equal. It checks if the value and the type are the same. Here, JS says, nope, one's a number, one's a string. I don't do the type gymnastics here. Use this when you want precise, no surprise comparisons, which is always. Not equal, lose inequality. This is the opposite of equal equal. Again, it ignores types and does the type conversion before checking. JS converts 5 string to 5 number, then goes, wait, they are equal, so I guess they're not equal? False. Yeah, feels like talking to someone mid-argument. Not equal value or not equal type. Strict inequality. The stricter, more predictable sibling of not equal. It returns true if either the value or the type is different. JS sees a number and the string and goes, different types, I'm out. True. If you ever unsure, default to strict equality and strict inequality. Loose equality is like borrowing your roommate's toothbrush, technically possible, but probably not a great idea. These ones are more straightforward. Greater than is the left value bigger than the right? Lesser than is the left value smaller? Greater than or equal to? Lesser than or equal to? And finally, the ternary operator. Now this one's fun. It lets you write a mini if in a single line. Perfect when you want to assign a value or conditionally render something without writing a full if-else block. It reads like this: if age bigger or equal to 18, then return adult, otherwise return minor. Super clean, especially in React for things like. Then we have logical operators. Logical AND, both sides must be true. Logical OR, at least one side must be true. And logical NOT, flips true to false and vice versa. Now onto the cursed operators. Just kidding, they're not cursed. Not like Annabelle who just got stolen. Seriously, who wants that doll? But these are fun-shaped. But first, what are bits? Computers don't really think in numbers like we do. Under the hood, they talk in bits, just ones and zeros. Every number, character, and emoji is just a bunch of bits arranged in patterns. So 5, that's 0101 in binary, and 1, that's 0001. That reminds me of the 00000.
Binary solo.
0000001
Good old days. When you use bitwise operators, you're manipulating those raw binary digits directly. Bitwise AND returns 1 only where both bits are 1. Here's a use case. This is useful for checking if a specific flag or permission is enabled. Example, you store user roles in binary. Why would someone do that? I'm also not sure. Is it faster? Bitwise OR returns 1 if either bit is 1. Use cases. Turn on specific flags without affecting others. Example, add edit permission to a view on a user without resetting all their accesses. Bitwise NOT flips all the bytes, 0 becomes 1, 1 becomes 0. Use case. Sometimes used in a low-level optimization or to quickly negate all bytes. Example for inverting a bit mask. Also a weird hack to floor numbers. So yeah, that was a lot of operators, but don't worry. You won't use all of them unless you're doing some hardcore low-level wizardry. And hey, I don't judge. You do you. Bit shift away. Now that we've built up all this logic, let's do something with it. Welcome to control flow. Enter the if statement. The if statement is how JavaScript makes decisions. The if statement always starts with the keyword if, followed by a condition inside parentheses. The condition should be a Boolean expression, something that evaluates either to true or false. If it's true, JavaScript runs the code inside the first set of curly braces, but if the condition is false, it skips that block and moves on to the else, if there is one, and runs the code inside that instead. JavaScript basically goes, is this true? Cool, I'll do the thing. If not, I'll do the backup thing. Let's add a little bit more logic. Here's what's happening. JavaScript first checks if age bigger or equal to 18. If that's false, it doesn't just stop. It keeps going and checks the next condition in the else if. This gives you multiple layers of logic to work through, one after another. And if none of the conditions match, the else acts as the final catch-all, the default block that runs when everything else fails. This structure is perfect when you're dealing with ranges, thresholds, or hierarchies. Things like age restrictions, score levels, or salary brackets where the logic depends on falling into a certain band. Sometimes if else gets the job done, but other times it turns your code into a long repetitive mess. Imagine you're checking user roles. You could write it like this. It works, but it's clunky, repetitive, and the more roles you add, the more the code stretches into an if-else mountain. Now imagine you had to maintain this, or worse, explain it to your future you at 3 AM. Not fun. That's where Switch comes in. It's built exactly for situations like this, when you're comparing one single value against a list of known options. Here's the same logic, but written with a switch. Now it's easier to read, easier to extend, and easier to debug. You match a value, take action, and break out. If nothing matches, the default kicks in. Clean, controlled, and at least slightly less painful than that if-else. But there's one more trick up Switch's sleeve, and that's grouping. Let's say guest and viewer should both have the same message. With if-else, you'd either repeat the message or wrap them inside a separate condition. But with Switch, you can just stack the cases. That's an interesting trick to have up your sleeve. And yeah, if you looked at the Switch block and thought that's just a longer version of what we already had, you're not wrong. I said the exact same thing when I first learned about it. Some people prefer it, some don't, so use whichever makes sense for your brain. Both do the same thing in the end. Let's tie everything together with a real-world example. We're building a tiny shop where logic decides your discount. Now, ignore all the HTML bells and whistles, the cards, the styles, the click handlers. I only made all of that so we could see the logic in action. What I really want to show you is this block right here, because this is where everything we talked about today comes together. We're grabbing the price from the clicked items, converting it to a number, because HTML attributes are always strings, and then adding it to the total using plus equal. Do you remember what it does? That's just some string concatenations so we can show the updated total to the user. But here's the fun part, the logic that decides which discounts to apply. We're using an if-else chain to check which discount tier the total falls into. We've got our comparison operator, like bigger than, to test the thresholds, and some basic arithmetic with multiplication to apply the discount, 30%, 20%, or 10%. We also use toFixed, which we didn't cover today, but all it does is round the result to 2 decimal places, just to make it look clean in euros. And that's it. That's the whole brain of the logic store. In the end, it all comes down to a few values, a bit of math, and a handful of if statements. Want to make it your own? Go for it. Change the prices, tweak the thresholds, swap the discount emoji so it doesn't look exactly like a certain Chinese shop. Right? It's just logic. You've got this. Today, we broke into JavaScript decision-making system. Operators, do the math, ask the questions, combine logic, control flow, act on the answers with if, else, or switch. You've now got the power to make JavaScript think. So here's your mission. Improve on the app we just made, add more discounts, maybe add a check to the user's country to see if we can ship to them. Go and see how real online shops do it. Can't wait to see what you build. Drop your version in the comments. And if this helped you out, give it a like, hit subscribe, and of course, I'll see you in the next dimension.